Alrighty, so today we're going to talk about solving rational equations. You can call this 8.5. It's technically the lesson from before spring break, or you can title it 8.10. It does not bother me. These are your steps to solving a rational equation. So feel free to pause the video and write down these steps. The main idea is that we're getting a common denominator so that we can take all our numerators and set them equal to each other. Once we get our solution, we have to make sure that that solution is an x value for which the function is defined. If we take that solution and plug it in and it causes one of our denominators to be 0, then that solution cannot be an answer. So let's look at a simple example like number 1. Okay. X plus 1 over 3 plus x minus 1 over 3 equals 4. Now what we notice here, which is really nice, is that we already have a common denominator. So since we have a common denominator of 3, we're going to go ahead and just take our numerators and set up a nice simple equation. So x plus 1 plus x minus 1 is equal to 4. All right, so that would give me 2x is equal to 4, which tells me that x is equal to 2. Now technically this is not a rational function or a rational equation because my denominators are not polynomials of degree greater than 1. So this is an example with fractions to show us how this works. Okay, so there would be no chance of an extraneous solution here. All right, look at number 2. Y minus 5 over y plus 1 is equal to 3 over 5. This is an equation that you learned how to solve back in Algebra 1 and geometry using something called cross multiplying. The process of cross multiplying, the reason it actually works is because you are basically clearing your fractions or getting a common denominator. Okay, so look at your two denominators, y plus 1 and 5. Would you agree that our LCD would be 5 times y plus 1?
Yes.
Okay, so I'm going to start by writing my original equation. And if you'll remember how we did this with adding and subtracting rationals, you basically think about what's missing, and you multiply the top and the bottom by what's missing. So what is this first fraction missing in the denominator?
5.
5. So I'm going to multiply the top and the bottom by 5. The second fraction has our 5, but we are missing y plus 1. So we're going to multiply the top and the bottom by y plus 1. So now that we have the same denominators, we can go ahead and set the numerators equal to each other. So that would give me 5 times y minus 5 is equal to 3 times y plus 1. You see that that's the same that you would get from cross multiplying. Okay, so that's really what we're doing. So let's go ahead and solve this equation. I would get 5y minus 25 is equal to 3y plus 3. So that gives me 2y is equal to 28. So y is equal to what? 14. What's the only value that y would not be allowed to be? -1. Every other y value is acceptable. So y equals 14 is a totally acceptable answer here. Everyone okay with that? Okay, let's move on to number 3. All right, what do you think we might do first?
Factor.
Good, let's factor this denominator. So x squared plus 2x minus 3 would factor into x plus 3 times x minus 1. Okay, so what would our LCD be? Good, x plus 3 times x minus 1. All right, so again, you might not have to do this every time, but I like to go ahead and start by writing my original equation and then think about what is missing. All right, so what am I missing from my first denominator?
X minus 1.
So I'm going to multiply the top and the bottom by x minus 1. In the second fraction, I've got 1 over x minus 1, which means I'm missing x plus 3. All right, anything from the last one?
No.
No. All right, so now that our denominators are all the same, I take my numerators and I set up a nice simple equation with them. Okay? So I've got x minus 1 plus x plus 3 is equal to 4. So that gives me 2x plus 2 equals 4. So 2x equals 2. So x equals 1. So then I compare that to my denominators. Is x allowed to equal 1? No. If I were to take 1 and plug it in, say right here, or right here, I would get a 0 in my denominator. Anytime you have a 0 in the denominator, you try and divide by 0, your function is undefined. So what that means is that the solution, x equals 1, is an extraneous solution. When you only have one solution and that solution ends up being extraneous, or if you had two solutions and they both are extraneous, then that means that this equation has no solution. So extraneous is a way to describe the solution x equals 1. The answer to this problem is no solution. Okay? All right, let us look at number 4. All righty. What do you think the LCD might be here?
No. 18 x minus 2.
It doesn't have to be 18 times x minus 2. Yeah, it's going to be 6 times x minus 2 because that 3 goes in evenly to the 6. Okay? If the 3 didn't go in evenly to the 6, then yes, you'd multiply them. Okay? All right, so let's take what we've got. All right, what do we need to multiply the first fraction on top and bottom by? 2.
Oh.
So I'm going to multiply the top and the bottom by 2.
Why by 2?
Because you already have 3 times x minus 2. So if I multiply by 2, that gives me the 6 times x minus 2. All right, so I have 5x over 6. So I need to multiply top and bottom by x minus 2. And what about the third fraction? 6. Everyone okay so far? All right, now that our denominators are all the same, I can take my numerators and set them equal to each other. So that gives me 2x plus 2 is equal to 5x squared minus 10x plus 6. What type of equation is that?
Quadratic.
It's quadratic. How do we solve quadratic equations?
Set it equal to 0.
Good. Get it set equal to 0 and then factor. All right, so if I set this equal to 0, I would get 5x squared minus 12x plus 4. How do I start factoring this?
Get factors 20 to add it and get 12.
Good. So I'm going to multiply 5 times 4, and that gives me positive 20. I need factors of positive 20 that add up to negative 12.
Negative 10 times 2.
Good. Negative 10 and negative 2. Now, does that mean that this factors into x minus 10 and x minus 2?
No, because there's
No.
a 5 coefficient in front of the x.
So okay, correct. We can't go ahead and just split this into our factors because we have that leading coefficient of 5. Okay, so we're going to go ahead and split our middle term. So this is 5x squared minus 10x minus 2x plus 4. All right, go ahead and finish factoring that and find your solutions.
Sorry.
All right, so hopefully you got this to factor to 5x minus 2 times x minus 2. Yes? Okay, so what are the two possible solutions that we get?
Between negative 2/5.
It'll end up being positive 2/5, yeah, and positive 2. So we check these solutions. Are there any that are extraneous? Good, x equals 2. If I were to plug in x equals 2, I would get a 0 in my denominator, which causes my function to be undefined. So your only solution here is x equals 2/5. Now, when I'm checking your work on your test, okay, I have to see that you got 2 as a possible solution and then decided that it was extraneous. Okay, so make sure you're not skipping steps here. Okay with that? Yeah.
So when you're going to check for extraneous solutions, that's all of them at the equal?
No, you look at to check for extraneous solutions, you check any denominator in the equation. Okay. Other questions? All right. Let's go to number 5. Alrighty. What might be our first step?
Factor.
Yeah. Let's factor our denominator here. So we get x plus 4 times x minus 1. All right. I want to draw your attention to this 1 minus x here. Anytime I see something like that, I know it's really close to x minus 1. Okay, so I want to try and do some manipulating to see if I can get it to be the same. So would you agree that I could rewrite 1 minus x as negative x plus 1? Would you agree that's the same? Okay. Yeah. And then I can pull out negative 1, or just a negative sign. That would give me positive x minus 1. The benefit in doing that is to make my LCD simpler. Okay? If you don't recognize it, you'll still get the right answer. Your LCD just will be more complicated and you'll have a little bit more going on in the numerators. So what I can see now is that I've got a negative and a negative. So one thing you can think of is negative 1/2 is the same as 1 over negative 2, right? So I can think about taking this negative and putting it on top. So if I subtract a negative 1, what does that end up doing? Adding. So what you want to think of this as is 1 over x plus 4 is equal to 2 over x plus 4 times x minus 1 plus 1 over x minus 1. Because we're subtracting a negative. Okay? Okay. So let's think about what's missing in the first fraction. Oh, sorry, what's my LCD? Good, x plus 4 times x minus 1. So what am I missing here? X minus 1. Nothing from the second fraction. And then x plus 4. Okay with that? All right. Let's take our numerators and let's set them equal to each other. So x minus 1 is equal to 2 plus x plus 4. Okay, what do you notice? Yeah, we have an x on both sides, so those cancel. So I end up with negative 1 equals 6. Yeah, that doesn't make sense. That's a false statement. Anytime you get a false equation or a false statement, what's our answer?
No solution.
No solution. Yeah. Questions? Alrighty, let's try one more. One over 1 minus x plus x over x minus 1 is equal to 1. Yeah, so again, in this situation, we're going to want to try and manipulate this 1 minus x. So I can think of it as negative x plus 1, and then I can pull out my negative.
Can you make it 1 over 1 minus x minus x over 1 minus x?
Say that one more time.
1 over 1 minus x over 1 minus x.
Yep, you could do that too. Okay, so I'm going to rewrite this. I'm going to take my negative and put it up on the top. So I'm going to write this as negative 1 over x minus 1 plus x over x minus 1 is equal to 1. Okay, so what would our LCD be? X minus 1. So the only thing I would need to apply that to is my final fraction. So I would multiply by x minus 1 over x minus 1. So would you agree that that gives me negative 1 plus x is equal to x minus 1? Yeah. So then if we start kind of combining like terms or thinking about canceling things out, what are we left with? 0 equals 0, x equals x, negative 1 equals negative 1, wherever you end up. Anywhere we end up, we get a true statement, right? Anytime we get a true statement, what's our answer normally? All real numbers. Now, this answer is not all real numbers. Why? Good. X cannot be equal to what?
1.
1. If I were to plug in 1, I'd get an undefined fraction or an undefined function. So the way we'll put that is that x can be all real numbers, or x is an element of all real numbers, but x is not equal to 1. So again, what that means is that x can be all real numbers except 1.
The x element of all real numbers, you only way to write it, or is it you write
What do you mean?
it?
I mean, you're solving for an x value, so you would want to have x in there. So yeah, you just kind of want to get used to the symbol as an element of. Okay. If I were to use x equals 1 and I plugged in 1 back up here, I'd get a 0 in the denominator, and if I divide by 0, I get an undefined function. Other questions?